Hi everyone, my name is Nina Derschlag, and for today's interactive advanced concept presentation, number 8, we will be experimenting with kinetic sand. So let's just jump into the materials you will need. So for one, you're gonna need some sand. So I've got some fun pink sand. Just made a bit of a mess. You're gonna need some cornstarch. You're gonna need some dish soap. I already pre-did the experiment just to make sure I can have one success out of the one fail that I had. So I only had to do it twice, which is good. So yeah, some dish soap, which, I used all of it. And then you're gonna also need some water, and then you're just gonna need some bowls. Oh, and then also I used a measuring cup, 1 tablespoon, and then just a spoon to help mix. So with all that being said, let's get into the procedure. So I used 3 tablespoons of cornstarch, and order of operation really is essential here. When you go and look at other videos, you will see the fails and the successes from what order they chose. So, after watching and reviewing, I chose to trial the success route. And I would say it semi-worked out for me pretty well. And so with that being said, I first had a bowl that I used, and I took 3 tablespoons of cornstarch, and then I drizzled a good amount of dish soap to where when I was mixing it, it was getting into like a good pasty texture. You don't want it to be too liquidy or too runny, because then your texture won't really be able to hold shape, which we'll get into later. And so I was just kind of gauging it off of the texture by mixing it, and I added probably 1 to 3 splashes of water in it just to kind of help if it was getting a little too chunky than what I wanted from the pastiness I was looking for. And so after mixing that, I then, in a separate bowl, had my sand, and then I was also gauging that off of just scooping 1 spoonful of sand into my mixture and just mixing that and seeing what consistency I was getting. And then I roughly had 3 total tablespoons of sand in my mixture. And so after mixing it all up, this is what I got. So here you can kind of already see it's kind of pasted up in here, but when I move it, it's got that good pasty texture to where it's sticking to itself, which I will get into later. So it's pretty thick, and when I touch it, it feels kind of like Play-Doh. Like it's a really fun and silky texture, which feels really good. And I almost feel like if I used maybe more cornstarch or a little less water even, it would have been less messy. But I mean, I can just pick it up like that, and I have like a little clump. I can even clump it into a ball like that, and it'll hold for the time being until it flattens, which I'll get into. And so I'm pretty happy. Like I said, it took me 1 fail to get another success, so I'm pretty stoked on that. So along with just getting into the science behind it all, we used the dish soap and cornstarch method. Another way to get this result is to also use the slime method. So then you can use like Elmer's glue and some liquid form of cornstarch. I've seen that also works as well. It might be a little less messy as well. However, for the purpose of this class, we are sticking with the dish soap and cornstarch. And like I said, it was a success. So let's get into kinetic sand experiment and what it demonstrates. And it is the topic of polymers. And so a polymer is a substance that has a molecular structure consisting entirely of a large number of similar units bonded together. Polymers are found based pretty much everywhere on the planet, and they have extremely large amounts of applications in the world. And so a lot of people actually don't know how widely used polymers are. So just a couple of things when you think of, okay, so like where and when do we use them? So came up with some examples. So polymers help us, one, save energy. Also, they help with lighter vehicles. They help with insulated vehicles and buildings. They help with packaging consumable goods. They help reduce land use and fertilizers, along with being very helpful within the medical settings, such as having easier ways to process and sterilize. They've got better shelf life, and they are also known to have a lighter weight. So just some examples. Kinetic sand and why the polymerization occurs. So here, kinetic sand is actually regular sand, but rather than the coat being in water, like we would probably commonly see wet sand that you find at a beach, it's actually coated in dish soap. So because the coating is dish soap and not water, the sand will never dry out, which is one of the best features of kinetic sand. So that's pretty neat. Whether if it be more runny than pasty, it will never dry out since it is covered in dish soap, which has that oily texture to it. And so kinetic sand is an example of a diluent or a non-Newtonian fluid that increases its viscosity under stress. So you can actually mold the kinetic sand into different shapes, but after some time, it will actually crumble into the form it was originally at. And so kinetic sand is normal sand that has been coated with silicone oil. And so silicones are polymers, meaning their molecules are made up of long chains of repeated units. And so silicone oil have unique properties, and they can be liquid that flow freely or semi-solids that flow in the absence of pressure but act like rubbery solids under stress. And so that is called viscoelasticity. And so a substance degree of viscoelasticity depends on the length of the polymer chain in the silicone oil. And so with the kinetic sand, the polymer chains with the silicone oil make the sand particles stick together, so you can form them into a ball, and which is why you can play with them the way that we can, kind of like Play-Doh. And that is because they only stick to themselves, and they won't stick to other things other than themselves. And so, I mean, you can put them on the table, you can put them on any other surfaces, make shapes, and they will hold that form. However, it won't stick to anything other than itself. And so, although, as you can already kind of see as I'm playing with it, it's flattening, it will do that over time, since the silicone oil coated sand particles stick only to each other. And so that's why it's not sticky and shouldn't be too hard to clean up. Obviously, I might have done or not have added something that I shouldn't have. And so it is a little bit more messy the way that I did it. Otherwise, I would say the consistency is what I originally did get. So I would say it's a semi-fail, semi-success. Anyway, that is why the polymerization occurs. Thank you so much for watching.